Hey, welcome to Meteor Brent's Education. Today, we're writing and solving systems of equations. So, let's go. Our Brent is shopping for a program to edit videos. The first program has a one-time cost of $150 and then a $20 monthly fee. The second program is $30 per month with a $50 one-time fee. So after how many months will both these programs cost the same? Alright, first thing we're going to do is write some equations here. We know we're looking at per month, so we have some months being used as variables, and we know we're talking about the cost. We're being asked, will the cost be the same? So cost, or I'll use C, is going to be a variable as well. So for that first program, the cost equals, how much you're going to spend on that first program, is $150, which is that one-time fee, plus the $20 per month, so 20 times M, the number of months. And that second program, the cost, C, equals 30 times M, which is $30 per month, plus that $50 one-time fee. All right. So this question is asking, how many months will the cost of the program be the same? How many months till that happens? So that means when are these C's on these equations here? When is that going to be the same? So we can assume that that C is the same on both the first and the second program. Okay? So if that's true, then I can set both of these equations equal to each other. Whoa, crazy! All right, here we have 150 plus 20M equals 30M plus 50. So right now we're trying to figure out when are these going to cost the same? How many months is that going to be? So we're trying to solve for M. We're trying to get that M by itself, or whatever your variable that you're working with, you're getting that variable by itself. And for myself, when I'm trying to solve these, I don't like working with negative coefficients, that number with the variable, if I don't have to. So I usually take the smaller value and get rid of that one. Like, what? Get rid of it? Yes, watch. If I subtract 20M from one side, remember, we're talking about an equation here, you got to do the exact same thing to the other side. So positive 20M minus 20M is 0. And then 30M minus 20 of those M's is 10M. See what I did there? This is kind of combining like terms, okay? We just took away 20 M's here. You got to make sure you're combining it with the same variables over here, or the same terms over here. All right? So what we're left with is positive 150 equals 10M, that's how many M's are remaining, plus 50. Hey, look, we have a two-step equation. We can do this. So I'm going to subtract 50 from both sides, because again, we're trying to get that variable by itself. And I'm left with 100 and 0 for those constants there. And then now we have 100 equals 10M. That's 10 times M. So we do the inverse operation by dividing both sides by 10. 10 times 10, or sorry, 10 divided by 10, not 10 times 10. 10 divided by 10 is 1. 1 times M is M. And 100 divided by 10 is 10. Just happens to be that way, okay? All right, so what we can say here, oh, wait, we gotta check our work. Because I could have made a mistake here, and I do make mistakes here, because sometimes I go so fast that I either forget like a negative somewhere, or I accidentally add or subtract something just because I'm trying to go so fast. So checking your work is a great way to make sure that what you're saying is actually true, okay? So how we do this is, we've said that in 10 months, it's going to be the same. So what I do is I'm going to substitute that 10 in for M on that equation. Okay? So I have 150 plus 20M, oh wait, it's 10 now, 20 times 10 equals 30 times 10 plus 50. And then now we're in the order of operations, and we're trying to figure out, is this equation true? If it's not true, then we made a mistake. And by true, I mean this is an equal sign, so that left side should be the same as the right side. Okay? So order of operations, 20 times 10 is 200, and 30 times 10 is 300. And then both these sides simplify to 350. So, yes, we did good. So now I can confidently say that on the 10th month, Brent will spend the same amount on either program. Okay, so beyond that or before that, then there's going to be one program that's going to be more expensive or less expensive than the other. But at 10 months, he's going to spend the same amount either way. All right, let's go to one other one. Ashley and Anna are racing one lap around the track. At a point in time, Ashley has ran 230 meters and Anna has ran 200 meters. Ashley's running at a rate of 3 meters per second, while Anna's running at a rate of 4.5 meters per second. How long will it take Anna to catch Ashley, and how far into the race will this occur? Whew, it's like a lot going on there. All right, just like before, let's write our equations. Okay? So Ashley at that distance equals 230, which is where she started from, plus her 3 meters per second. And Anna, that distance equals 200, is where she started from, plus 4.5 meters per second. And now, again, we're trying to figure out when are they going to catch each other, so when are they going to be the same? So that distance is going to be the same. So that means we can set both these equations equal to each other. Boom. So now we're going to say that we did before. I'm going to get rid of 3s because it's smaller than 4.5s. So I'm going to subtract 3s from both sides. 3 minus 3 is 0. 4.5s minus 3s is 1.5s. That means the difference in speeds is 1.5 meters per second. So we have 230 equals 200 plus 1.5s. Here's a two-step equation again. So I'm going to subtract 200 to get rid of that. I'm left with 30 equals 1.5s. Now one-step equation. This is 1.5 times s. So I'm going to divide both sides by 1.5. 1.5 divided by 1.5 is 1. 1 times s is s. And 30 divided by 1.5 is 20. This is saying 20 seconds. However, that's not all this question was asking. Okay? But before we get into how far into the race this is, let's make sure we did this part correct. Okay? So let's check our work. So we do that by taking that 20 and substituting it back into that original equation. So 230 plus 3 times s, times 20, equals 200 plus 4.5 times 20. And then now we do order of operations. 3 times 20 is 60. 4.5 times 20 is 90. And then we simplify both sides. They both equal 290. Yes, we did good. Again, I make mistakes sometimes, so it's really good to check your work because chances are you're going to make some mistakes at some point as well. All right. The question I was asking, how far into the race will this occur? Because I can pretty confidently say it's going to be 20 seconds into the race. So what I'm going to do is get a little piece of paper if I don't already have one out, which you probably should. By the way, this may seem like a lot of steps. It kind of is, and that's okay. And I'm going to take that 20 seconds, s is 20, and choose one of those equations, either Ashley's or Anna's. It doesn't matter which one. I'm going to pick Ashley's just because it's nicer looking. It doesn't really matter. Okay? Actually, I'll do Anna's. Why not? It really doesn't matter which one I pick. Looks like I forgot which one I chose earlier, so that's okay. See, mistake. All right, so now I'm just going to substitute that 20 in for s, and when I simplify this right side, I just plug in the calculator. 200 plus 4.5 times 20, and that distance is 290. So now I can say that it's going to take Anna 20 seconds to catch Ashley. And by the way, this is going to be 290 meters into the race. Okay? You might have noticed that when we're checking our work, we really did this middle part already. All right. So if you want to see more examples like this or see what we're doing at Mirrorverse Education, then visit us at mirrorverseed.com. Thank you for watching. Hope you have a great day. Adios.